What I'm going to do sort of systematically, I'm going to start with the first derivative so we can find our stationary points, see where it's increasing, decreasing, then go to our second derivative to find our inflection points. Sometimes doing our first derivative and second derivative, we're going to find maximum and minimum points and inflection points. Sometimes those will also be y-intercepts and x-intercepts. If we haven't found all of those y-intercepts, x-intercepts at that time, then I'll look back and see my original equation. Could I easily find my x-intercepts? Could I easily find my y-intercepts? And add those to my graph as well, and then draw the sketch. Okay, so starting with our first derivative here, 3x squared minus 4, and then setting that equal to 0. 4/3 equals x squared. So x will equal plus or minus 2 over root 3, starting off with wonderful numbers. Despite them being wonderful numbers, we can still put them on our negative 2 over root 3 and 2 over root 3 on our graph here. Try a large negative number. This section will be positive, increasing. Try 0, you'll get negative, decreasing. Try a number bigger than that, it'll be increasing again. So we already know that negative 2 over root 3 comma something is a local max, and 2 over root 3 comma something is a local min. Someone figure out those values for me. Someone tell the values they have, and then someone else can verify.
I found it where it was be about
3.07 and negative 3.07. Verifications, did other people get the same ones? You got the first one negative as well? So both of them negative? Okay. Anybody else? So now we've got close, but
I got 16 over 3 root 3.
16 over 3 root 3. But positive?
Oh no, I got the same thing, but I just did it as a
Okay. So that is equal, and you had positive, negative? Okay. Just doing a quick check here. If I put a negative number in here and then add a number, depending on that number, it could be positive or negative. I'm going to keep with these ones. I don't think you can go from a maximum down to a minimum and have the same y value there. So it makes sense that this local max is positive and the local min is negative. Okay, so there we've got our local max and our local min, either as a decimal, and some people kept it with the square roots. Going up here, I'm going to change colors and go to my second derivative. Which will just be 6x. When is that equal to 0? When x is equal to 0. And checking before 0, we're going to have negative. So that's going to be concave down, and after 0 is going to be positive. So it is an inflection point, and lo and behold, there's our y-intercept and one of our x-intercepts. And this is going to be an inflection point. So now we know our curvature, we know our inflection points, we know our maxes and our mins. The only other thing I would check is, can we find any other x-intercepts? So how do we find x-intercepts? We set y equal to 0. Notice you can factor out an x, and then we have a difference of squares, x plus 2, x minus 2. So x equals 0, which we already knew, but we also know that x equals minus 2 and x equals 2 are other x-intercepts. Two over root 3 as a decimal. Just for graphing and for making these a little bit easier, I'm going to write them both as decimals right now, so I'm going to keep the 3.07 and the negative 3.07. And 2 divided by root 3, negative square root 1.15, just so we get an idea of where we can put these. And this one, yeah, this one's negative, and that one's positive. So now when we go to our graph, we've got our local min and our local maxims, just sort of going to get a sense of all of our points. They're all really close. So I'm going to set up a scale this way. We know we have 0, 0, negative 2, 0, and 2, 0. We're going to have 1.15, negative 3.07. And negative 1.15. And positive 3.07. We know that our function is going up, then going down, then coming up again. It's concave down. Woo! Yes, perfect, right through that point. And concave up after. And there we have our first graph. Okay, so we could find our maximums, our minimums, our inflection point, and also 2 x-intercepts, all without our calculator on this one. We did need our calculator, though, to calculate these values, although some of you did them without a calculator to get the 16 over root 3. However, to graph it, to get a sense of where you would put that point, the decimal is a little bit nicer, just for familiarity with what that value looks like.